Thanks for the introduction. I think the first time I participated in this conference was 2001 or 2, something like that. And at this time, I was talking all the time about dioxin. So what you presented today was something I was talking several years about, but then the topics changed over the time. So today and now I want to talk about the determination of the biogenic CO2, which is also a quite important topic for the moment, and which is also realized with such automatic samplers like we produce since many times for dioxin or mercury, and now the biogenic CO2. I will take a look first on regulations. What we do now with the determination of the biogenic CO2 is mainly driven by emission trading systems. And I give you here an overview. It's the status of 2024. And it's from the ECAP status report of this year. And we see there are more and more countries with emission trading systems, so it's not focused anymore only on Europe. Also Canada has more. In US there are several states which follow that. And we see also in Asia or India, South America, countries which are in preparation for an emission trading system. The interesting or important part for us is that only fossil CO2 emissions are traded. And so if there are biogenic CO2 emissions, there is not necessary to buy credits for that. And that's in all emission trading systems the same. So this is then very important to determine the biogenic and fossil fraction, but that's not really important in cases like coal-fired power plants or gas turbines. It's clear everything is fossil. But if we have mixed fuel, like in waste incineration, then this is getting quite more important. So this means on the other side, the determination of biogenic CO2 is only interesting if waste incineration or the waste sector is implemented in the emission trading systems. And here's an overview about the different trading systems and which industries are covered. And actually, waste is included in Australia, New Zealand, South Korea, Germany. Interesting, US state of Oregon, it's new. So even if the central government in US drives different directions, there's already now one state which also include waste incineration, and there are even China's pilot ETS systems. And then there are plans to include waste in the ETS in UK. That should be done from 2028, and in the European Union, the Commission wants to decide next year in July if this sector will be implemented from 2028. If we look on the different emission trading systems, in Europe we have the EU ETS. This was founded, or let's say starting in 2005, and it was the first worldwide ETS system. And it includes industrial plants such cement kilns, iron steel, power plants. And since 2024, so since last year, the incineration sector is obliged to monitor. And from, as I said, in 2026, there will come the final decision by the Commission if they will be implemented from 2028. Then we have the UK ETS. They decided that they have to monitor from next year and should participate in national emission trading from 2028. Then we have our special case in Germany. We have a so-called Fuel Trading Act, and there it's also mandatory since January last year that the operators have to report and to trade CO2 emissions, but once again, only the fossil part. And this means that, once again, the fossil CO2 mass must be determined. All emission trading systems are then also accompanied by monitoring, reporting, verification rules, or you can see also MRR. So there are different appreciations, but at the end it's how to monitor, how to determine the total CO2 emissions, and how to determine the biogenic fraction in case of incineration. So, and they are mentioned as input, let's say, measurement, periodic waste sampling, followed by analysis. So they put every 5,000 tons of waste, they are taking some grams of the waste, and then they are analyzed in different methods. So it's a, let's say, a random analysis. Then there's mentioned the balance method. I think we will, after my presentation, we will hear more about that by Professor Fellner. So that's a method which was developed by him, and it's also written in ISO standard. Then there could be CO2 flue gas sampling, adsorption on a cartridge, and then analysis by carbon-14. And there could be also a calculation by emission factors according to the waste key. That's something which is used, for example, in Germany in this Fuel Trading Act. There were different assessments in the last couple of years. Last year, the UK government was doing an assessment for the UK ETS, and now in July, there was an interim authority response of the governments of UK, Welsh, and Scotland. And at first, they decide now that from 26, there should be a voluntary emission monitoring period. So it's not obliged now, they change it a little bit. And as monitoring methods, it's definitely written that the most accepted method is continuous emission monitoring systems. So SEMS for the CO2 and the flow, and for the determination of the biogenic fraction, the carbon-14 analysis. Only as an example how this could look like, though this is a table from our Fuel Trading Act, from the monitoring requirements in Germany. They are depending on the different waste key, what the operators have the license to burn. There are emission factors for the total CO2 and also for the biogenic fraction. And if we take, as an example, residual waste, there will be emissions of 0.864 ton CO2 per ton of waste, and 0.4 ton of that will be fossil, according to these factors. Only as an information that there are different technologies and solutions how to measure total flow, and sure we have this in our product range to measure the total stack volume flow. We have models, we have analyzers to measure CO2, but also other greenhouse gases like N2O or methane. This can be done by extractive measurement or by in situ with laser. If we look on the determination of the biogenic fraction, and I show here a scheme of the method of EN ISO 13833. So it's a continuous extraction of flue gas on a CO2 adsorber material. We use mainly soda lime, and after a sampling period, which could be manually by some hours or automatic like a system we have, we sample 1 month. This cartridge is taken out, the next cartridge is taken in to start sampling, and the used cartridge is sent to a laboratory and is analyzed according to the carbon-14 method. And with that, it's possible to determine the biogenic and fossil fraction. The part is that biogenic material consists of carbon-12 and carbon-14, whereby fossil material only consists of carbon-12. So this is coming from the archaeological determination of the age of anything, of bones or something like that, and here it can be used to determine the biogenic and fossil fraction. And here is an overview about our system. We call this AMESA B, for biogenic, and the sampling principle fulfills all the requirements of this EN ISO 13833, and as I mentioned before, we are able to sample up to 1 month. And here's some pictures how it looks like. So we can sample on horizontal or vertical ducts, and all the instrumentation is included in such a cabinet, in a small cabinet, and everything is operated by touch panel. So it's quite easy operation. We took this over more or less the manual driving like we know since 30 years from dioxin sampling. Come to results. In the meantime, we installed more than 100 of these systems. So the interest, I have to say, is quite big. The main market actually is UK. And also in Germany, we installed in the meantime more than 25 systems, whereby several of these installations were temporary for several months. Because the main method in Germany by the operators to determine the total CO2 and the biogenic is up to now this calculation by emission factors. That's something they have done before, that's something they know, and so that's the main used method. And several operators installed our system directly, and others said, okay, let's see what is better for us, calculation or measurement. And if we look on measurement, I have here results from a different kind of plants. If we go from the left to the right, in the left is a biomass plant, which is burning reclaimed wood and sewage sludge. And we can see in an average, they have around 76% biogenic, what we expect if it is mainly biomass. But it varies between 66 and 86%. So we have variation in the biogenic content of a factor of 20%. And that's something I always say we have to be careful if we calculate with emission factors. Then we have an example, an RDF plant, which also burns reclaimed wood, plastics, and also sewage sludge. Here we have an average 52%, but also we have variations of around 10% biogenic. And we see that also in the others. So there are fluctuations. And